Well, hi, good morning, and thank you so much for joining me in my shop. Today is August 17th, and if you look at the radio, you can see I've already taken the tuner box out of it, and I think the first thing we're going to do is look this thing over very carefully. You know, there's quite a few omissions on my part. The last time I had this box out, I didn't even look at these other components carefully. I really didn't do all I could do. I was just pretty sure if I did those 5 capacitors, we'd be home free, but not so. So I'm going to get the camera here, and one of you noted that I'm up to like video number 23 or something like that, like 20 videos. That's 20 shop sessions with this radio, and you asked just how many do I think it might take. Well, the last time I did a TW2000, that was 5 years ago, 60 videos. I hate to say that, but I believe it's 60 videos, and in the early days of my YouTube career here, it wasn't unusual for me to do 40 or 50 videos on one radio. Okay, because they were much shorter. They were 10-minute, 15-minute videos then. Okay, let's get that camera going here. While you're trying to figure out what that is, I am going to fix the focus on this camera so it doesn't try to automatically focus. Just give me a moment here. And we'll loosen it up about like that. Okay, let's go hunting. So there it is. That capacitor on the left there, the 0.01, does it look 0.01, eh? That's interesting. That's a fairly large capacitor. I would have thought they'd use a wax one or a molded one there, but they did not. This is all pretty awkward in here too, in terms of trying to work. Probably use these disc capacitors because they're small and I can pack a bunch in here. It's just way up in there. I can barely see it with my eyes. Boy. Even with the unit out, it's still so crammed and tight in here. Okay, this last section. Just looking for anything that might leap out at us. I'm looking at that resistor. Is that normal? At the end of a resistor, see where it's blackened around where the lead goes in? Is that a normal thing? That's a big resistor. I think that's a 1 megohm resistor there. Okay. I'm just assuming the turret itself can't be responsible because it's every time you turn it, you get a different set of components. So how could it be consistently a problem? That's about all I can see up there. Gotta take the turret out and get a better look. there's a groove here that this is writing in, so this has to come straight up. So I've just done it the wrong way here. This side first. It's very strong spring here. I can rotate it out. No. Still too hard. Sometimes the simplest stuff, eh? Straight out, straight out. That's the secret. Straight out. Okay. Now, we didn't really reveal much more in here. Just a resistor or two. There's one tucked up in here. Okay, so I'm going to get out my ohm meter. I'm going to try to test these resistors as best I can. Maybe we'll find one that's open or something like that. And the capacitors, I'm not sure yet. I think I'm just going to whip through them with an ohm meter. Coffee time though. Well, I've gone through and tested every resistor using this ohm meter, and they all check out. In fact, a lot of them are right on the money, dead on. And I've checked every capacitor in here using this device, and they all show capacitance except for two of them. Two of them show up as a defective component. So I'm going to test one of these. Are very small capacitors, and I suspect that's what's really the problem. They're small, and my tester is balking. Let's see what it says. So that's what it reports. The other capacitor here is the very same size, which is quite suspicious. But the problem really is my instrument here. Oh, excuse me. Oh, now I get it. Okay. Let's see. Right here. Right here. Not clip on there. Okay, nobody move. Get the same thing. No unknown or damaged part. So the capacitance is too small, I guess, for the unit to pick up, so it decides there's nothing there, or the part is damaged. Well, these two capacitors, one is going to the antenna input terminal. Whoops. And the other one is going to the whip antenna input terminal. So the input signals from either input here, the whip antenna or this, are passing through these two capacitors, which are showing up as defective. But I doubt they are defective. That's hard to believe. That has nothing to do with the oscillator. I haven't taken that approach. You know, what could bring down the oscillator and go look for those parts in particular. But having tested them all, just for interest's sake, what happens with this device if you test a shorted out item? It's a resistance of nothing. Such a smart device. Well, I'm going to go and drink a little coffee and just ponder the situation here, but I don't think I've found anything yet. Somehow I thought staring at the schematic might help, so I've been staring at it, and look at this interesting thing. I was looking at these, I was thinking about what's coming into the box and what's leaving the box. and looking at these lines, and AVC, B minus, bias. Huh? What's that? Bias. So if we go back here, we see it's coming from this point where it says 6.4 volts positive, is what it says there. We follow the line along. It comes up through this huge 3.9 meg resistor. I don't remember measuring that. Somehow I missed that, or I measured it wrong or something. From there, the bias is applied on the other side of this resistor. Now there should be no current flow through here, so there should be no voltage drop here. So whatever voltage is over here should be over here, 2.4. So that, I guess, tells you the drop across here. How can there be a drop there? There must be some current flow up this way or something. Something going on like that. Yeah, I don't want to study that just yet. Wow, is there any case? Well, there must be cases where defects up in here can stop the oscillator. There would have to be. I mean, there's components in the oscillator circuit that are being changed to change the oscillator rate. But you think then if I change band, I would find sometimes oscillator working, sometimes not. You know what? I didn't really do that very carefully. What I did was I went through the different bands. They all sound dead. I didn't really look for the local oscillator, as I remember it now. So I got to find this guy and measure that. But it's really got nothing to do with the oscillator circuit, does it? This bias is being applied to the signal grid. Unless, well, it's going up here. Well, it's not going up there. There's a capacitor there. It's not going up there. It's not going over this way, of course. And I found this voltage to be correct. I measured the drop across this tube. I don't think I ever measured it across that one, or I didn't check this voltage carefully. But if this one's correct, I guess you could kind of assume all this must be correct too. So I'm barking up the wrong tree here. Look more closely, like this one, like this 180. Did I remember reading a 180? That does ring a bell when I was testing the resistors. Something that would affect everything would be, this guy, or this guy. Because this is the only in and out from the oscillator part of the tube circuit. Yeah. So this is the in and out. So I did measure a 10K inside the box. It was 10K exactly. I guess if you're snapping these in, you would find variations down here from the components being snapped in and out up here. Of course, there's nothing in right now. While I'm doing this, the turret is out. So these are all open. Well, so what I've done with these capacitors so far is I've just checked them for shorts, mainly. That's really what I've done. I should check these for value now. So we'd have to locate them. How are we going to do that? I don't think there's any diagram that shows you what's what. The position and the location of them inside. There's no diagram in here doing that. That would be real helpful if they did that. But I don't think there is such a thing. There goes the turret there. And these guys, they just cover the, whoops, I can't stop on time here. They just cover good. Was there something more up above here? I should really learn to work a computer. That would be good. Not helping. Well, there's nothing in the manual here that's going to help out with this, I don't think. So we have to do is study the schematic and just poke slowly from known things like the tube pins and find these components and test them again very, very carefully. This time be aware. I think I should really print this out. Then I can mark it off. That's my plan. Coffee time once again. Okay, so I've carefully tested the 4 resistors that are in the circuit that involves the oscillator. They all are right on the money. There's nothing wrong there at all. So now I'm working on the capacitors. All the capacitors are accessible this way. Again, I'm just focusing on the oscillator, and I've just picked off the first capacitor, and this is the result I get. It's in the circuit, of course. Can you read that? 45 microfarads. What? 45 microfarads? How do you get that? It should be picofarads or something of that sort. ESR, I've never seen the K come up before. So it's 150 ohms. I guess that's what that really is. This looks like a bad capacitor. Let's try another one right near it here. You know, testing these things in circuit, you gotta wonder. And I think this tester has the ability to do it, but I guess it would be only under certain circumstances. I would think. So here's another capacitor. Let's see what this one says. 226 picofarads, no loss. That's more what I would expect. Well, I think what I can do is I can lift one leg of the questionable capacitor here, the little guy here, and test it again, and then we'll know what the story is. And I'll end up replacing this anyway, because the leads will be too short, and they might as well, once it comes out, you might as well put in a new one. So why don't I just cut it right out? Why fiddle around? Clip lead, please. So the clip lead is a memory device for me. Remember where this came from. And the other lead is just going to a terminal on the tube there. It's going between tubes. I don't know. So I don't know on this circuit which one this is. And my guess is I'll nip it out and it'll read just fine. Come on out of there. Hope I got enough lead left on it. 270. Isn't that one of the ones that was on its way out? When the signal leaves, goes up. Well, it wouldn't actually leave. It would be inside the turret. Okay. So 232 picofarads, no loss, and it's supposed to be 270. Yeah, I don't think there's anything wrong with this. Okay, I may have to go like this, component by component. This is terrible. I gotta replace this now. 270, and on the schematic it's 270. And this is one of the capacitors that the signal must go through to get up into the wafers. So everything goes through this capacitor. And the fact that it's a little low, I'm sure that wouldn't, I mean, this is not part of the oscillator, really, is it? Yeah, I guess it is, kind of, I'm not sure. No, I don't know. I don't know. 270, I'll put a new one in there. And I've been standing here staring at this for a little while. Uh, every component that I've tested tests okay. I haven't concentrated on the oscillator side. I really didn't. There's a couple over here, but how could they? How could they? Who knows? There's a little capacitor here I can try testing. Oh boy, it's so... It's so busy in here with wires going in every direction. Okay, I think I'm on that capacitor. No unknown or damaged part. Okay, and then the other. Oh, I see what I did. I followed the wrong wire. So there's a, what is that? Poker, please. Looks like it goes right there. Oops, wrong one. This one. Okay, I think I'm across the capacitor this time. 248 picofarads. So, and it says right on it, 270. So this can't be bad. And is there any other part? Just these little ones that I tested earlier that I've left in because I just don't believe it. I could always try feeding a signal. I can't because I have to put the radio together and the turret sits on top and you can't get at these afterwards. Oh my. Well, we have reached an impasse. So it appears as if every component is correct and functioning inside here. All the voltages appear to be correct. Yet it won't produce an oscillation. Tube appears to be strong. Used two different tubes, got the same result. I think the second tube showed a slightly better result. Even though I cannot detect the local oscillator, or when I've tried I haven't been able to really detect it. It seems to be there because the radio does work to some degree, and it has to have a local oscillator to mix to enable a sound to come out of the speaker. There's no way I could tune stations if the local oscillator wasn't operating. What if it is operating and I've just been foolish in how I've tried to test it? So to try to break that, I brought my other radio out, used the SDR to see the local oscillator in my other radio. It was quite apparent, and I then tried exactly the same test on this one, and no. In fact, my other radio had all kinds of spurious signals in it, generated, I assume, by the mixer action and just everything getting all mixed up. And this guy, quiet. There was no similar thing happening. Every indication is if this oscillator is oscillating, it's very, very, very weak. So weak, in fact, I can't even pick it up with my SDR using a coil. Using this. I suppose if I connect the SDR directly, but of course that loads the oscillator circuit. And the thing about oscillators is often there's quite a bit of voltage swing in them. I mean, they're really going at it. Want to put that on your SDR? I don't think so. What else is there? what else could be happening here? How else can I check it? How else can you check this? Oh boy. Let's look at the capacitor here, and you can see these outside plates here have really been bent out. Look at them. So that's a factory operation. You can see how far they've been bent. And this one appears to be bent out slightly too. Well, that's part of the alignment process, a part I never attempt. This one looks like it's bent out slightly too. So like in the factory, they can probably, you know, do this effectively, especially with some experience after you've done your first 50 radios. Well, oscillator not oscillating, no idea why. This is a common pit to fall into with a radio. Seldom has it happened to me this bad. But oscillators are a little tricky. It doesn't take much to upset them. Well, I'm thinking, can I operate this outside the radio and avoid reinstalling it each time I want to fiddle with it? The wires are this way. I mean, it would go in like that. I could probably make all the wires reach like this. I can have this thing sitting here. What the problem is, the necessary contacts up into the turret are not contacting. What if it's that simple? That's far-fetched. That's a far-fetched idea. The radio has worked. It's just worked very weak. So we're just right back to a weak oscillator. The oscillator is strong, but the oscillating effect is not presented to the radio. That would be the 270. No. Presented to the radio. It's not presented to the radio. It's presented to. Yeah, it is. It comes out and goes to the. No, it doesn't. It goes to the tubes in here, Jim. It's all contained. It's all contained. So, what's coming out of the box is simply the feed into the IF. There's nothing else coming out of the box. Although there's stuff coming out into the turret. Can there be a problem in the turret? I did not check for every band. And I'm repeating myself now, but that's what happens. I start going over things again and again. Okay, I got a few things to think about here. So one of the things I've heard a number of times about oscillator problems like this is if you try a series of tubes, you'll find, one of them works when the others don't, for reasons that are beyond everybody. Is that the case here? I've tried 2 tubes. I know for sure the tube I tried worked because I have it in a radio that works. So I know the tube is not a problem. Put it in the tester, both tubes are testing okay, one a little stronger than the other, but neither one functions in here. Yeah, okay. So I went through the chance that I made an error or something dumb happened when I was replacing these. And there's nothing to be found. Everything looks great. Wow, how do you proceed with this now? It's really a problem because the only way to operate it, at this point anyway, is to reinstall it. The thing about reinstalling it is then you can't get the turret in and out. If I could operate it outside the radio, then I could put the turret in, take it out, and fiddle around, do stuff. Would it behave dramatically different if it were outside where it's supposed to be? Probably not, particularly if I ground this to the chassis. Shouldn't really be a problem. I should be able to do it. That would mean probably having it like this. This is a convenient way to do testing. I need to have it somehow sitting about like this. Wow, there's a real problem here. These two shorter wires go to this coil right up in here, and you have to get it right up there I'd have to extend these wires a bit. The rest of them I think are long enough to do the trick, but not these two. Come on, won't something just jump out at me? I'm waiting for something to jump out and go, hey, look at this. Look at this thing. There's a lead there, soldered right to the chassis here. Oh, you know what that is? That's going through this capacitor over to the A. No, wait a minute. No, I don't know. Anyway, this contact just goes straight to the chassis here. It's a little small. You might have an easier time seeing this than me. If it focuses. Presto. So we're looking up in these things a little bit, these contacts anyway. And what am I doing? What am I doing? I'm saying third one over. These numbered? Third one over. They're numbered on here. Yeah, look, this one here comes right to the chassis, along with these other connections. That means you're providing a chassis connection up into here, like that. Not helping any. You seem to just make more and more observations until suddenly something happens. Did I check that resistor way up in there? I probably did. Maybe not. Okay, another resistor here I may have missed. You know what? And this capacitor didn't get soldered right. Yeah. Jimmy. But we're going to test a resistor right on the terminal there. I'm going to leave it unsoldered for now. Find me my... Is this it? This is the one thing I missed and it's the thing? Okay, so there's a wire loops around here and the other end goes here. 16K, I believe is what that is saying. 16K. So it's attached to pin number, I don't know. Pin number. Wow. 2. I'm not sure. 3. Sometimes these have pin numbers written right on them. Yeah, they do. 1. Wait a minute. It can't be 1. That would have to be 1. Oh, there we are. 4. Okay, so I can see the numbers. And what am I doing? I forgot what I was doing. looking for this resistor. Resistor is hooked up to pin number 3. Resistor in question is on pin 3. Pin 3. Pin 3 of the oscillator tube. Pin 3. This is so small. You know what? I'm going to hold that up and look up on the TV screen. There we go. Pin 3. Where's the resistor on that? There's no resistor. Oh yes, there is over there. 107. 65K. It's really tied between 3 and 5. 65K between 3 and 5. 65K between 3 and 5. Okay, so this is one end of it for sure. And I'm pretty sure this is the other end. Anyway, these pins can't be side by side. There's got to be a pin in between. Definitely it. Well, they're supposed to be 2 pins apart. This is on the. This is not the oscillator. This is the RF tube. So I'm looking at the wrong part of the schematic. So we're looking at, I would say, 6. And, oh my gosh, I don't know. 6. Way down there. 1, 2. Oh, I can't see them. I'm trying to count the 1, 2, pin 2, and pin 3. Pin 2 and 3. Looks like pin 2 and 3 of the oscillator of the RF tube here. Between pins 2 and 3 there is a 15K resistor. 15K. And look, off that resistor is the signal's tapped off, heads to the mixer oscillator. This is doing a couple jobs. This is just an amplifier, this one here. Okay, 15K. Can we read 15K on there? 15K. Like that. And we touch this. It's only me. I don't know why I talk in the plural. Here we go. 16K instead of 15. Okay, well, not a problem there. I really can't imagine the small variations going to cause the oscillator to just not produce. You know, so I guess the incorrect voltage here, which I don't know, is that focusing? The -3 that's supposed to appear here right above my finger. Get my hand out of there. That always comes out as +2. The green dots mark me finding the resistor in question and testing it and finding it to be okay. That's what the green blobs are. Oh my! Going back to the try another tube thing, I don't have another tube to try. Works in one radio, not in this one. Okay, so another thing to do would be to get the other radio out, and I'm not about to do this, but just as an idea, and start comparing voltages between radios and look for something that's out of sorts. I mean, that's virtually impossible because everything has to be put back together and then it's all inaccessible. What can you do? Well, I think what I got to do is try to make this thing operate outside the radio like this, so I can fiddle around with it do tests on it, take it apart quickly, put it back together, do more tests, that kind of thing. Did I really test every capacitor that's in here? I'm pretty darn sure I did. They all look familiar to me now. The other thing about oscillators is sometimes, or radio circuits in general, the positioning of things can be critical in affecting the operation of the radio. So what I believe to be true is, in some radios, the position of the components need to be exactly where they are, or the radio won't operate the way it could operate if everything was done exactly the way that they did it in the factory. So one of the things I used to do, which I don't do anymore, or I don't do very often, is look for alternative ground points and move components around. Oh, it's easier if I hook it over here. It's just a ground point. What does it matter? Well, maybe in some cases it does matter. So I guess what I'm talking around is the idea that the oscillators operate on a knife edge. And you get a little bit off the knife edge and it just won't go. And none of it sounds believable to me. There's nothing to see. There's nothing to do here. Okay, before I lose my mind, I'm going to stop for today. Tomorrow I'll think more about this during the day, but I'm probably going to try to make this thing operate kind of outside the radio. Goodness knows that that's even possible. And the idea is it gives more opportunity to poke around and test. Poke around and test. Okay, well, have a great day. It's been raining here. So that's good, because there's hardly been any rain this summer. Hardly any. Okay, see you later.